to quickly get straight to the point where I give you a very quick lesson regarding how you deal with questions related to Theorem of Pythagoras. So remember, we've got different types of triangles, but in today's lesson I'm going to specifically focus on this type of a triangle, which is called a right angled triangle. Maybe let me start by doing this and say this is a triangle, but it is not a right angled triangle. I'm not guessing. There is something that should tell me whether a triangle it is a right angled triangle or not. So it can only be a right angled triangle if it has that corner at the box, which is a 90-degree angle. So that means it doesn't matter whether it is drawn like that. As long as it has that, it is a right angle triangle. If it is drawn like that, if it does not have that corner there, it is not a right angled triangle, even though it may look like it is, but because it does not have that, it means it is not. Until there is a statement which says this triangle it is a right angle triangle, then we will know. If we are not told, we don't assume, we don't guess, but this is what should give us the confirmation that this is a right angled triangle. So now let's come to the second part of this. Something that you should know, especially at your stage, is that when you have a drawing like this, firstly ask yourself a question to say, is this a right angled triangle? Yes or no? It should be a no. Why? Because we don't have that confirmation that it is a right angle triangle. However, it does look like it is a right angle triangle. So I must do that, then you will be sure that it is a right angled triangle. So as you can see, a triangle has got three sides. Not only that, but it also has three angles. So which means we have side 1, side 2, side 3, then angle 1, angle 2, that being the angle as well. So let me focus on this one and say, okay, this is the side, but there is something special about the side facing or opposite a right angle not a right angle triangle, but facing the right angle, facing that corner there, which is that side. For this triangle, it will be that side. And then for this triangle, it will be that side. For this triangle, it will be that side. This side is called the hypotenuse. But at this stage, you might not need to worry about that, because we're going to look at the formula to calculate questions related to this type of a triangle, and we will refer to that as the R side. So it's either you call it hypotenuse or the R side. I'm going to explain that very soon. So now, since you have this as your right angled triangle and we've got this hypotenuse or the R side, something that you should know about it is that it is always the longest side of this right angled triangle. So that means here you have side 1, side 2, and side 3. Side 3 will always be the longest. So that means if side 1, let's say, is 20, and then this side it is 10, this side it must be longer than 20 or longer than 10. The moment it is 13, then you know something is wrong, because hypotenuse is always the longest side. If this side is 3, that one is 2, this one, it must be the longest side, must be greater than that or greater than that. Then in this case, we can't talk about what I've just explained, because this is not a right angled triangle. What I'm talking about now, it only applies when you have a right angled triangle. Then in this case, if you have 7 there, and then here you have 3, this side, the hypotenuse, the longest side, or the other side, must be greater than that 7. Obviously, that one is smaller than 7. So it's greater than the longest of those two. So now let's come back to this one. And now I would like to talk about the formula. The formula for theorem of Pythagoras says r squared equals, you can say x squared plus y squared. This r, it refers to the side. This x refers to the side. This y refers to the side. So you can see it has 1, 2, 3 terms. So the r side is the one that I've just spoken about, which is that longest side. This is the r side, this is the r side, this is the r side. When it comes to the x side and the y side, at this stage, when you are in grade, it could be 8 or 9, you only care about the r side. When it comes to the x side and the y side, you can choose any. That is why, for me to firstly understand this topic, I had to say, okay, I know I've got the r side squared. This must be equals to side 1 squared that I plus it with side 2 squared. Because the moment I know this is the r side, this is side 1, I can say this is side 2. It doesn't matter if I refer this side as side 2 and then that one as side 1. Maybe let me give a different sketch and do that. I have to do that corner so that it's a right angle triangle. The side facing that corner, it is the one that we call the r side. Then this one you can call it side 2. This one you can call it side 1. If you want to use x and y, you can call this side x, you can call this side y. Another one can call this side y, another one can call this side x. It is still okay. That's what I mean when I say when it comes to x and y, at this stage, you can assign it to any side between those two, as long as you know that the r side is that one. Doesn't matter how it is drawn, whichever way it is drawn, honorable members, you just need to know that the side opposite or facing that 90 degrees, it is the r side. Then you can refer to this as side 1, that will be side maybe 2. Doesn't matter whether you refer to this as the x side, this one as the y side. So that's all that you needed to know with regards to an introduction. So what I'm going to do now, it is to actually start with the calculations. I'll do just a few so that you've got a sense of how you use that formula. I hope you did understand all that I've explained. So very quickly, let me start with the calculations. I'll just start with something simple. Maybe let's do that. Let's say we have 90 degree there. Okay, maybe, let's see. Let me actually try to get an example from my list. I'll be back just now. Let's see. I want to find an example that will not have the decimals. So that's why I need to therefore look for something. Okay, it's fine. I think I've got something that I can use as an example. So let us say we have that as a triangle. Let's say this is A, this is B, and this is C. Let's maybe say this side is 12 centimeters. Then maybe let's say this side it is 9 centimeters. I will just need to remind you that the formula says r squared equals x squared plus y squared. This is the formula that you will always use the moment you realize you are having a right angled triangle. I hope that makes sense. So now what I'm going to do, it is to apply that formula. Maybe for this first example, let's say interpret this as if we are saying r squared equals side 1 squared, that you plus it with side 2 squared. So in this case, your R side, it is that side of AC. Then side AB, it could be your side 1, and then side BC, it is your side 2. Now let's try to substitute. So we have our R squared, which is equals to, there is the formula, whichever way you interpret it, it's fine. But what I'm doing now is to substitute. Side 1, it doesn't matter whether you start with that 9 squared, that means you will have your 12 squared there. Another one can start with a 12 squared plus 9 squared. It doesn't really matter that much. So you continue to say R squared is equals to, what is 9 squared? Let's see, 9 squared, it is equals to 81, that you plus it with 12 squared, it is equals to 144. Then you continue to say R squared is equal, what is this plus that? It gives you 225. Remember, what we are calculating, it is not R squared, but it is just R, the R side. So you need to remove that squared. You can remove it in many ways. One of the other ways in which you can remove it, you can square root both sides, meaning you will say square root of that R squared equals 2 square root of 225. And then that's how you remove that squared over there. The next step, you just write R, which is equals 2. If you punch that on a calculator, it therefore gives you 15. Remember, in this case, you must not just write it as 15. You must always check if from the original equation you were given any units. In this case, we are dealing with centimeters. You must therefore write it as 15 centimeters. I hope that it does make sense. So I'm going to do it where I use those letters A, B, and C, and this time around I'm going to try and be a little bit faster so that you've got a sense of how fast you should be in an exam. Okay, maybe if you are on an advanced level, remember that R squared, to remove that R squared, you can just say that squared, you can multiply it by 1 over 2. You just need to remember that whatever that you do on the left, you must also do on the right, so that that squared cancels with that, then R to the exponent of 1 is the same as that. If you punch this on a calculator and you say 5 to the exponent of half, or 0.5, or 1 over 2, it will definitely give you 15. Then you say centimeters. That's what I mean when I say you can work it out in many other different ways. Okay, then let's see, what else did I want to talk about? I wanted to say R, since it is a length, it will therefore be a positive value. So that means at all the times when you calculate your R value, it will always be positive. Otherwise, I can also say when you calculate the side or the length in mathematics, it will always be positive. So now let me continue and do it a bit faster, but in a different, not necessarily different way, but using those letters. So what I've just explained regarding the R being positive, you will later in the next grades understand what I mean by that. So, okay, what I would do is that I'm given triangle ABC, I'm given the X side and the Y side. but I'm not given the r side. Okay, so the formula says r squared equals x squared, that you plus it with y squared. So that means that side r being the r side, it is actually the side AC, not side AB. So that means a side AC squared will be equals to, and I can just say side AB squared plus side BC squared. So what I'm doing now, it is to rewrite that formula to suit that triangle that I'm given, which is in letters of A, B, C. Therefore, what I will do, it is to substitute and say my AB side AB is 9 squared. At this stage, you don't necessarily need to substitute the units. You just remember that in the end, your final answer must be having those units. So what did we say? This one is, nope, not that. 144 is 12 squared, but this one is 81. So that means we've got 81, that we plus it with, I think we said 1044. Then we end up having AC squared, which is equals to 225. Then you square root both sides. You must show it as you square root so that we know what happened to that squared. Then your AC, it's equals to, what did we get? We got 15. You just need to remember to say centimeters. So that's how you would work it out. So now I'm just going to remove all of this and then look at a situation where you need to calculate either the x side or the r side. Okay, let me quickly find a doable example. This time around, maybe let me use small values. Let's see if I do that, and then I plus it with that. Okay, it gives something else. Let's see. I'm trying to see if I can find an example which does not have the big values. Maybe let me use this one. I think it should be fine. Let's see if I say that and I plus it with that, gives that. Okay, let's maybe try to look at this one. Then let's say we are having 5 there, and then we are having 3 there. Again, maybe let's say, okay, this is A, B, and then C. Doesn't really matter that much. So now I'm about to start it. Something that you should be aware of is that the formula says r squared equals x squared, that you plus it with y squared. You should always know this formula. Then whichever letters that you are given, you can rewrite this formula accordingly. But most importantly, before you do much, you must always know the r side. If you do not know the r side, then you're going to be in trouble. You might get it wrong. Because the moment you know your r side, you'll be able to substitute correctly and know what you need to calculate. So now let's see. The r side will always be the side facing that 90 degree, as I've explained. So it therefore means if I have to rewrite that formula according to those given letters, I'm going to say alphabetically B comes first. That's why I will say BC squared, being that, equals whichever side. I can say AC or AB. So let me maybe just say AB squared, that you plus it with AC squared. Then now I'm going to substitute my BC or other side is 5, then you have a squared. AB, it is 3, then you have a squared, plus AC. So it looks like side AC is the one that we are looking for. So the question is, what is 5 squared? 5 squared is 25, should be equals to 3 squared, it is 9. Then you say plus AC squared. Then let's see what else. Then now you just need to solve for AC. You transpose, you need to take that to the other side. You end up having 25 minus 9, which is equals to AC squared. What is that minus that? Let's see, 25 minus 9. It gives you 16, which is equals to AC squared. Then you will say AC squared. Okay, you need to remove that squared. You are therefore forced to square root both sides. That's what you will always do. AC squared. Therefore, that's how that squared is removed. And then square root of 16, it is definitely 4. And then that means 4, it's equals to AC. If you like, you can write it nicely by starting with the letters and saying AC is equals to 4. Do we have the units in this case? Nope, we don't have the units. Then I can just leave it as it is, which means that side it is 4 units. I am now confident that that answer is correct. Why am I saying I'm confident? It's because I know that when I calculate, the x side and the y side must always be smaller than the r side. So this side must be smaller than that side, or that side must be smaller than that side. So if I get a value which is smaller than that, it gives me the confidence that I might have done it correctly. But if I got a bigger answer, then I would know instantly that something went wrong. But I would just not be 100% sure if my answer is correct. At least I'll be knowing that this is the value that I'm expecting, bigger than or less than the R value. So this is how you should then be working the questions related to theorem of Pythagoras, where you're dealing with a right-angled triangle. I think it might be worth it for me to mention that this is what you must not do. If you just have a triangle, it could look like that. You must never use Theorem of Pythagoras in any triangle. You only use in a triangle that is a right-angled triangle. So it must have that. Only if it has that, then that's when you can use the formula. But if it doesn't, then you must not use the formula. I hope that makes sense, and I'm hoping that it will assist you to do some more exercises. So I think I will end it here for today.